Very frequently in statistical methods, we use descriptive statistics to talk about measures of central tendency. That term sounds fancy, but what it does is it tells us where the average person lies, where the average scores may fall, and so on. So measures of central tendency can tell us a lot about a population. So if you don't know much about a group of individuals and want to find out, a way to do this is to gather some data and then take the means or the averages. And these measures of central tendency can tell us a lot about the population. So measures of central tendency, they are calculations. So the previous presentation we talked about counts and percentages. Counts aren't calculated, we just count them. And then percentages obviously are a calculation, but from the counts. Measures of central tendency take potentially are a little bit different because they are calculations from the data or a closer inspection of the data. And the goal with measures of central tendency is to tell us what the value or values are that are representative of a group. So for example, if you're studying cross country or triathletes, for instance, and you want to examine some aspect of their behavior and how it affects performance, very useful for you would be to know things about the group, such as age. Triathlons are, include a wide range of individuals. So if I choose a subsample from that group, and you work with triathletes, you may want to know, hey, how old were they? Are they similar to the age group you work with? So often you'll see age, in a population given as a range as well as a mean. So the average person is 35, and the range was from 20 to 73. Or the range maybe was from 30 to 40, and your mean was 35. Very different groups, right? Knowing the measures there. So let's talk a little bit more about measures of central tendency. And they are going to include the term mean, the term median, and the term mode. You've probably heard all of these before. Sorry if this is a review, but certainly the mean you've probably heard before. It's an average. It's the average calculated using arithmetic, right? So it's where we take a sum of all of the scores and divide by the total number of values. So again, it's a calculation where we add up all of the different scores and we divide by the total number of people, and we come up with the average score in that particular activity or category or, again, attribute. The median is a little bit different. The median is if you were to lay out all of the scores on a line, it's that middle score. So it's the very middle score. The median is where 50% of the scores are below that number and 50% of the scores are above that number. So it is the true midpoint of all of the scores. Typically, especially in large sample sizes, it's very close to the mean, but it isn't always, and we're going to see some examples why here in a minute. The mode is the most commonly occurring score or value. So again, typically near the middle, but not always. Often you may have a bunch of people scored really high on something, and then people trickled off. So we're going to look at these different options here and some examples on the next couple slides. But all of these are considered to be measures of central tendency. So let's do some calculations. And I'm serious. Let's do some calculations. If you have 7 people that all run a 100-meter dash in a lab that you're doing in class, and these are the scores, luckily they're all whole numbers, what is the mean of this group of individuals? What is the median? And what is the mode? So calculate the mean, obviously, by taking all of these numbers, adding them together, and dividing by 7 because there's 7 people that did the test. That'll give us the mean. Then find the median, and then find the mode. And once you have, go on to the next slide. So feel free to hit pause. Okay, so you all did that, I'm sure. and found very interesting information. So my class, the lab that I just performed, where everybody ran these different speeds, and I have some speedsters in there, believe me, we end up finding that if we add all the numbers and divide by 7, the mean speed in my class was 13.6 seconds. So the average person in my class runs at a speed of 13.6 seconds for 100 meters. The median is the middle score. So you lay them out from smallest to biggest. And since there's 7, we take the fourth one. This is the middle score because there's 3 below and 3 above. And that gives us a 13 seconds. So the median score is 13. So that means half the people were below that person, half were above. If there's an even number of measures, you actually take the average of the 2 middle scores, unless they're the same. The mode is the most common score, so the score most commonly gotten in my class was 11. These are all slightly different measures of central tendency, and they all tell us, again, if you come into my class and you run a 14-second 100-meter dash, that you're in the slower half of my class. You are on the bottom half of the mean. You are certainly below again, the number's bigger, but it's below the median in terms of performance, and you're on the slower end of the class. So again, those give us some very useful information and tells me that I have a class that actually is very fast in general based upon those scores. Now, I always wondered, why don't we just use the mean? Why do we need the median? Why do we need the mode? Well, the median and the mean are both very useful. The mode is just kind of interesting in terms of it tells you what's the most common measure found. However, the median and the mode can tell different things because sometimes the mean can be thrown off, especially in small samples, if you have someone that's considered what we call an outlier. So if I change the speeds in my class, if I change the slowest person from 18 seconds to 25 seconds, maybe they're just really slow, maybe they have something that prevents them from running very quickly, but I have this one person that really is an outlier, very different score than everybody else. That throws my mean off. If you look here, what that does, that one slower person changes my mean by over a second, or by a second, to 14.6 seconds, which puts them way out here, almost at the third slowest person. And what that does is, instead of having a nice curve of things, it skews the curve. It pulls the mean and the median further away from one another and kind of misleads us as to what the average score is. That's why the median is useful, because it is not disturbed by an outlier or two, because it's that middle score. So it does tell us still half the people did better than 13 seconds and half did worse than 13 seconds, even though we have an outlier. So those two measures are going to be very, very helpful. And often when we're talking about performance measures, we often see both displayed. Another way that we see, again, this data or central tendency displayed is with frequency distributions, which really are counts and percentages, but then often they're presented in what's called a histogram. In histograms, we've grouped data we've grouped data that is typically interval data, so it's not categories. So before we were talking about counts, now I want to talk about forcing interval data into counts. On the bottom of this chart, you can see weight. Weight is not a category, right? We measure it as, it could be 150 pounds, it could be 160 pounds. But what they've done is they've put the people by weight into groups. So they've grouped weight for every 5 pounds. So this first bar is 150, or it's every 10 pounds. So this first bar is 150 to 160. So anybody that falls in that range is here. This is 160 to 170, 170 to 180, 190 to 200. So again, what we can see by putting interval data into categories, we can then create what's called a histogram. You'll frequently see this for age, where they'll group people into 5-year intervals, 10-year intervals, and so on. But again, it allows us to look at interval data, but in again, kind of forcing it into categories and giving us a interesting display. What this specifically is showing, and I don't know that this is accurate, this is NFL data. These are defenders. This is the average weight of these individuals. So we see that there are very few individuals, maybe 1 or 2 that fall in this category, versus there are almost 200 people that fall in this category, just below 200 pounds. And then we see a drop off, then up and down. And that kind of, again, shows us the different weight distributions for people in the NFL that play defense. Again, another way to display data that gives us an idea of where the central tendency is, because we can see that the middle range is around 250, but we do have this cluster of people just under or around 200. We have a cluster of people at 250. Then we have another cluster just above 300. Another important aspect of central tendency is variability, right? Variability tells us how much spread there is between the scores. Are the scores all very close together, or are they very spread out? So again, if I was to look at something like weight, body weight, and I want to compare it in sports. In football, we have a pretty wide range of weights. We have people that are fairly smaller, 150, 160, 170 pounds. The defensive, some of the defensive players, the defensive backs, the wide receivers might be on the smaller side. We have some very heavy players on the line. And then we have a lot of people grouped in the middle. But there's a pretty wide range of weights when we look at a distribution of the population. So what we see in this example chart above is how far away people are from the mean of the scores. So if we take the average NFL player's body weight and measure how many people fall, 10 pounds, 20 pounds, 30 pounds, 40 pounds, and so on, away from that mean, we get a curve like this, maybe like this green one, where there's a pretty wide distribution, right, of weights. If we graph the same thing, but we look at female gymnasts, we're going to see that there's much less variability in their weights, right? They're all a similar height. They're shorter. They all have a fairly similar weight. So if we were to show the distribution of their body weights, we wouldn't get this green line necessarily. We would get this red line where everybody's really tightly packed around the average weight. Okay, so we might see something like this. And then if we were to take the body weight of the general population, we may get something like this with a much wider distribution. So that idea of distribution is a measure of variability. How much do scores vary? Same thing, if I was to take a bunch of sprinters, measure their sprint speed, and look at how close they are to the mean, we'd get something like this red line. Everybody's really fast. Some are a little faster, some a little slower. Versus if I was to take just a random group of people and measure their sprint speed, I'm going to get this much more wide distribution of scores, further from the mean, because there's a lot more variability. If I choose random people from society, I get some fast ones, I get some slow ones, and I get a bunch in the middle. So anyway, this idea of variability is just that. It shows how far these scores are spread out. The term spread is an actual statistical term. It is the highest score to the lowest score. So often, if we're looking at performance data published in the literature, we'll see the highest score. How fast was the fastest person? How slow was the slowest person? Or how heavy was the heaviest person? How light was the lightest person? The range is also often shown as well, and that's just the difference between the high score and the low score. So if the highest weight of a person was 200 pounds, the lowest weight was 150, then our range would be 50. Our spread would be 150 to 200, our range would be 50. Quartiles are a way that divides the data into 4 equal parts. So we can say you are in the top 25% of the people based upon your sprint speed, or you're in the bottom 25%. Again, gives us an idea of where people fall in terms of 4 equal parts. And really, we can see quintiles, which are 5 equal parts. We can see groups of 10, but, so we know what, break it into 10%. But again, there's all different ways to do that. But it breaks them into these equal parts. Standard deviation is a calculation that you'll frequently see combined with the average or mean of a score. The standard deviation is a calculation that determines the average variability in a measure. So often we'll see things stated like the mean was 25 plus or minus 3. What that plus or minus 3 is the standard deviation. It tells us that the average was 5, but we saw on average the majority of the people falling plus or minus 3 from the mean. If the plus or minus is 7, then that means the deviation is a little wider, the variation is a little wider, and so on. So the standard deviation is a calculation that determines the average variability. We're going to look at that in more detail on the next slide. And then the variance is still, it's the same thing as the standard deviation. It's the squared of standard deviation, and it again is a calculation that helps us evaluate the average variability in a measure. Often some measures are more stable than others, and we see wider ranges of variability. We'll learn as we read more articles how standard deviation can really give us an idea of if there's a difference between the groups. Because again, if we do a training technique with 2 different groups of people, and we see that one has a higher mean than the other, which makes us think that it was better, but we see a very wide variability, so much so that there's a lot of overlap between the 2 means, then it probably means there wasn't a lot of difference between the 2 measures or 2 treatment techniques. But measures of variability are going to be key along with the measure of central tendency in looking at how much spread there would be. So again, if we look at this figure here, this red line, the red line obviously indicates the mean is right here in the middle, and this is the spread, right? The spread is very small. The high score and the low score are pretty close together. That would also mean the standard deviation is very small in this group. So the standard deviation is probably less than 1 if these numbers are the difference from the mean. The standard deviation is probably less than 1. Versus in the green line, the means might be the same for these 3 lines. The means are the same, but we see the variability is greater in the green line than in the red line, with the standard deviation probably being somewhere between 1 and 2. And then finally in this blue or purple line, the standard deviation is much bigger than the other 2, meaning that the scores were much more variable, ranged over a much larger area.